Today I'm going to be teaching you about oxidative phosphorylation and how it is accomplished. Oxidative phosphorylation is a generation of ATP within the mitochondria in a reaction sequence that requires coenzymes and consumes oxygen. ATP is the energy produced through the transfer of electrons from either NADH or FADH2 to a O2 series by a series of electron carriers. Although it is not produced directly through the ETS is creating the conditions necessary for the production. The way I am going to demonstrate oxidative phosphorylation is through the use of the electron transport chain. The electron transport chain is also known as ETS and is a series of compounds found within the inner membrane of the mitochondria. Now I am going to give you a brief overview of the structure that I will talk about more later. As I said earlier in the definition of oxidative phosphorylation, the transport occurs via the electron transport chain in the mitochondria. As you can see in this picture, the cytoplasm is surrounding the mitochondria. This is the inner membrane space. This is the region between the inner membrane and the outer membrane of the mitochondria, and the mitochondrial matrix is the extracellular fibers and the ground substance of connective tissue. The inner mitochondrial membrane is the membrane that sets the mitochondrial matrix from the inner membrane space, and the outer mitochondrial membrane encloses the entire organelle. Now I am going to zoom in on this picture and show you what is happening at a more intricate level. There are multiple steps to this process, and I am going to go through each step in detail to understand it better. Step 1. In this step, electrons are starting at NAD and going to oxygen, stopping at 3 different places where the hydrogen is moving from the matrix to the inner mitochondrial space. Electrons are a subatomic particle with a charge of a negative electricity. To explain this further, NAD is an electron carrier molecule that assists electron as it passes from the glucose to other passageways. This is the electron's starting point. NAD is being reduced into NADH by losing an electron, and the electron is going to help carry the hydrogen from the mitochondrial matrix to the inner mitochondrial space. NADH requires the enzyme flavomononucleotide. Flavomononucleotide is another tool for assistance that helps carry the electrons through the electron transport chain all the way to the oxidase and then helps the formation of water. So like I said previously, NAD is being reduced to NADH. NAD lost an electron, which is now here, and NADH is going to push the electron and the hydrogen up to the phospholipid bilayer. The hydrogen is going to continue to the matrix, and the electron is going to bind with a flavomononucleotide, which is going to help assist in the transport. The electron is going to grab another hydrogen, and it's going to continue on. The electron is going to grab one more hydrogen because it has 3 stops, and then the flavomononucleotide is going to take the electron to the oxidase, which is going to bind to the O2, which is creating water. Now, in the second step of oxidative phosphorylation, FAD is being reduced into FADH by losing an electron as well. So, FAD is an electron acceptor in this process as well. During this step, the electrons are being carried by the ubiquion and have 2 different places to stop, allowing hydrogen to move from the matrix to the inner mitochondrial space. Ubiquion is a tool assisting the carrying of electrons through the ETS and is also known as the coenzyme Q. So, now the electron is going to have 2 different places to stop. So the FADH is going to push up the electron and the hydrogen to the phospholipid bilayer. Hydrogen is going to continue. The electron is going to bind to the ubiquion this time, which is going to help move it. The electron is going to grab the last hydrogen, pull it up to the matrix, and the ubiquion is going to continue to push the electron to the oxidase. The electron is going to go down, bind to the O2, which is going to make water again. Oxygen accepts the low-energy electrons, and with the hydrogen ions forms water. The electrons were carried across the phospholipid bilayer by the ubiquion and the flavomononucleotide, and when the electron met the O2, the product was completed, producing H2O. Now, the last step of this process is going to include a proton, a hydrogen atom, and ADP. The hydrogen is going to come down into the matrix, binding with the proton and the ADP, and to produce ATP, which is the final step that everybody wants. And here you have the process of oxidative phosphorylation.